Welcome back. If you are finding these videos useful, consider liking and subscribing, and always feel free to leave me your comments or questions. I can fine-tune this content to whatever needs is going to suit you guys, so let me know what you think about the videos. So in the last video we talked about some basic variable stuff. Let's talk about basic functions and how functions are created and used in Rust versus Python. So let's create a function in Python that we're familiar with. We'll say, let's just call our function like printer. Let's make it take no arguments. And of course we use a colon. And let's just have it print, we'll just have it say print hello world. Okay. So we have a function here, printer hello world. Now what's interesting is in Python, if I don't define this function before I want to use it, I won't be able to actually access that. So you can see that if I call printer in my main function, this is not going to work. So you can see I get an error here. So I actually have to define this before I call it. So now printer is defined and it will run. So keep that in mind because that's not the case in Rust. So I'm going to move that up here. But I'm going to show you in Rust, we can actually put it down at the bottom. So let's create an equivalent code in Rust, and you'll see that it's very simple. So in Rust, to create a function, we're going to call fn for function, and we'll call this printer. Same thing, we'll have no arguments. And instead of a colon, like before, we're going to use a curly brace to separate code blocks. So this is our function printer with curly braces. And we'll call the print line command, which is similar to print in Python. And we'll say hello world. So you can see these codes are starting to look very similar. And I'm getting a red squiggly. I haven't used it, so let's put it into our main function. Printer. And you can see that even though I've declared printer, this function, after the main function, that's okay. But in Python, that doesn't work because the entry point for my application is here, and it jumps back to main. So it never actually had a chance to create, to instantiate or define this function printer. So when I run this, I'm going to get an error. Versus Rust, which is known at compile time, so it's able to identify this printer function. So if I run this, this should work. And there you go, hello world. So that's actually nice. We can define our functions wherever we want. It's kind of similar to C++ if you're familiar, where you have header files all over the place that define your functions and things like that. But luckily in Rust, we don't have to deal with those header files. We can define the functions wherever we want. So you can see that these two codes are very, very similar. So let's take this one step further. Let's have our code take an argument. So in Python, we would just say our argument, let's just call it our text. So we would just define it with a name like that. And we could say print text. Very simple. And we'll do printer and we'll say hello. So I can now pass an argument in there and run it. Very simple. So let's look at how do we implement this in Rust. Well, it's very similar. First, we're going to define our arguments inside of the braces, just like in the parentheses, just like in Python. So we're going to give it a name, so let's call it text. But the one difference here is we have to declare what type of a value is going to be passed into this function. So we can't just say text and leave it like this. Python is able to work with this kind of abstractly. We've got to tell Rust exactly what we're passing in. So in our case, let's pass in an @str. Don't worry about this @ just yet. We could also pass in a string, but we'll just pass it in this way. And let's say print line text. And now we will, print line, we got to put this in a formatted string here. So we'll say text like that. And now we're getting an error here because we're not passing in a string. So let's pass in a string, hello world. And let's run our program. And you can see it runs just the same. So that's great. So now we have equivalent code bases. The only difference again with the arguments is that we have to specify the type. Now there's another critical difference with argument types between Python and Rust, and this is one of the things that I don't like about Rust because I personally find them very useful in Python, and that's default values. So for example, in Python I could say, I'll just put my name in there, I can define a default value using the equal sign here. So I could say text equals Frank, print text. Now I can call this in Python with no argument, and when I do that, if text doesn't have an argument, it's going to use this default value. So that's something that I like a lot with Python. Now I understand that that can lead to less clear code, it can lead to errors, harder to debug errors, things like that. But I personally like the flexibility. But let's go back to Rust. So I cannot do something like this and define a default parameter. There's no syntax for that. That doesn't work. So in Rust, we must pass in the arguments that we are saying we are going to pass in. In this case, it's looking for a string. And if we don't pass that in, it is not going to compile. So that's one big difference. Another big difference is, and it's kind of similar to this same issue, in Python we could have different number of arguments. So I might say let's pass in an int like I and comma text equals Frank. So this would allow me to do things like printer 1 comma test. This would be valid because I'm passing 1 into this I and I'm passing test into the second argument, which is text. I could just say printer 0. This is going to assign 0 to I. It's going to assign the default value to text. So similar situation. We cannot do something like that in Rust. We must provide the exact amount of arguments that the function is expecting, and all of the arguments must be provided. So that's some of the basics on functions and how they are applied. Now, the good news is because Rust is so strict in this point, functions are very predictable. You know that when you see a function with a certain number of arguments, that in the code, those arguments must be provided by the code. So there's no default values. You won't be fighting default values, trying to figure out where certain values are coming from. So that can help you on the back end. Now let's also look at return values. So what if I have a printer here and we'll just say that this is going to return a Boolean true, if it was successful, let's say. So I could say, my val equals printer, and now val will be holding this return value of true. So I'm going to print. This function is going to print this default value. Let's fix this so that it's equivalent. Let's get rid of the default value so that our Rust code and our Python code are kind of similar. So I have printer, and we'll say print hello world. But the difference now is in my Python code, I'm returning a value. I could return the text, I could return a Boolean, doesn't matter. Let's just focus on the return functionality. So in Python, we just have to add a return statement, and it could be blank. That just means the code's going to return at that point. That can be useful to break early. Or we can say return and then some value, and that means that that function now is going to return that value. We don't need to really declare what that value is ahead of time. Some languages like C++, they might say, bool, printer, where you have to define the return type. Python does not require that. Now in Rust, we are going to require explicit definition of the return type. So in our case, if we want to return a Boolean, the way we're going to do that is we are going to add this function, this syntax. So right now, without this syntax, that's telling Rust that this does not return any parameter, or any value, which it does not. So there's no error. But as soon as I add this, so I'm going to add a dash and an arrow here. So it's like an arrow pointing to the right. And I'm going to put in the type that I'm going to return. So let's say I return a bool value. You can see now that I have a little squiggly, and the squiggly is going to say that this doesn't return this Boolean like it's saying it is. So the function is expecting somewhere in the code to return a Boolean, and it doesn't do that right now. So we need to do that. So how do we do that? Well, it's very similar to Python. We can say return true, with a semicolon, and now this function is going to return true. And just like in Python, I can say, let val equal print, and now this val is going to hold, I'll slide this over a little bit. Now this value, val, is going to hold a Boolean, in our case true. So true is going to be stored in value. After this function returns, it's going to return that value, and it's going to print hello world. So we have equivalent functionality. The main difference here is to do a return statement in Rust, we need to use this operator here, this right-hand arrow, along with the exact type or types. So if we wanted to return two values, like a tuple, for example, like true, and let's say the value is 0, then I could do a similar thing in Rust where I return a tuple. So I'll put it in a parentheses, just like in Python, so a tuple. And instead of returning a bool and nothing, I'm going to return a bool and let's say an I32. So again, now I'm getting an error. It's saying, okay, you're telling me that you're returning a tuple of a bool and an I32 together. You're only returning a true. So let me fix that. So I'm returning true, and let's say I return 0. And now it's going to work properly. Now this is going to be an error because this is, of course, expecting a bool and an I32. So I could say let val, and we'll say I. And you can see now val and I are going to store those respective values. So it's going to behave very similar actually to Python. So here I could say let val I equal printer. And it's going to return true in val and 0 in I, in the I variable. So very similar functionality between the two languages. Now, the last thing I guess I'll talk about right now, just to avoid confusion, is you're going to see a lot of Rust code that does not use the return statement. So let me clean this up just so that it's a little less confusing. Let's go back to just returning a single bool. And let's go back to just returning true on the Rust side. So ignore the Python for now. Let's slide this over. And we'll say let b equals printer. So we expect b to hold a Boolean value. Now what I can do is I can remove this semicolon, and I can remove the return statement, and I can save this. And you can see I'm not going to have an error. So it's a little bit interesting. So because I do not have a semicolon here, what I'm telling Rust is that this is going to be the result of this entire code block. And the result of this entire code block will then be returned. So when I have a semicolon here, that means that this is a statement, and that statement's just going to be true, and it's going to end. But there's no statement returning a value. But when I remove this semicolon, this is kind of like the end of, this is what's going to be the result of this entire code block statement. So by removing the semicolon and the return keyword, I'm now saying that this entire curly braces is resolving to a value of true, and that's going to return a Boolean now. So really you have two ways of doing return values in Rust, just to avoid confusion. You can say return with the value, which is just like Python, but you need to use a semicolon then because it's return true. That's a statement when you use the return keyword. Or you can remove the return keyword and remove the semicolon, and this has to be the last line in your function, and that's going to be what this entire code block is going to resolve to. So typically in Rust, the preference is to use this for kind of the end of the code block, for the resolution of the code block, and you would use a return if you're trying to return early. So I might have, and we're getting ahead, we haven't talked about if statements, but they're very similar. So I could say if, let's say text, something. Then I might say, return false. So I'm going to use the return here when I want to maybe return early, but typically in Rust, we're going to let the code block resolve to this last line. So in this case, it's going to resolve to true. It's going to return true versus me breaking early and maybe explicitly wanting to return false early. So that's a typical paradigm that you're going to experience when you look at other Rust code. But keep in mind, that this is perfectly valid as well. You could use the return statement at the end. There's nothing wrong with that. It won't have any impact on your code. But the idea is that the inference here is that this is kind of the result of the entire execution versus this, which is maybe a specific early return for some purpose. So that can kind of help you differentiate the intention there. But again, that's totally optional on how you want to use that. So that's kind of a primer on functions between Rust and Python. And you can see that there's a lot of similarity, but just a little bit more strictness on the Rust side. So I'll see you in the next video. Thanks.